Today we're doing section 5.3, logarithmic functions. The first thing we're going to do is switch back and forth between logarithmic form and exponential form. And that's what this formula is telling us. Okay, so this is logarithmic form. Log base A of x equals k. And this is exponential form, x equals a to the k. So here in our first problem, they give it to us in exponential form and they want us to change it to logarithmic form. Well, first of all, label all the pieces. Until you get used to doing these types of problems, label the pieces, okay? Notice in exponential form, the number that's being taken to a power is a, the power is k, and the number that's by itself on one side is x. So we can label each of these pieces. So this number that's all by itself, that's x. So x equals 625. This number that's being taken to a power, well, that's a. So a is 5. And the power is k. So k equals 4. Okay, well, these variables represent the same variables as over here. So we can just plug in the numbers that we got for each of the variables. So we've got log, my a was 5, so base 5, of my x was 625, equals the k was 4. Okay, you'll get used to where all of these pieces fall, but until you get used to it, go through and label each of the different variables, and then you can just plug them in. It makes it very easy. Let's go the other direction. So part B, they gave me log base 3 of 81 equals 4. Okay, now they gave us the problem in logarithmic form, and they want us to change it to exponential form. Okay, so again, now look at your logarithmic form and label all of the pieces. So we can see that the a is 3, the x is the 81, and the k is 4. And now you'll just plug these variables into your formula over here. So the x was 81, so 81 equals, the a is 3, and the k is 4. Okay, so you'll have a few in your homework changing it back and forth between the different forms. Practice that because that's just going to help us in a future section. Okay, so the stuff we're learning in this section is just building up to section 5.5 where we're going to put it all together. So you definitely want to start practicing these things. The next thing I want to talk about is the inverse properties. Okay, and the first inverse property, if you're given log base a of a to the x power, if these two numbers match, then this all simplifies to just the power. And that's going to help us simplify our logarithms. Okay, so this is a very important property. If you see that these two numbers match, then this all simplifies to just the power. And I'll show you how to use that in a few minutes. Okay, and our second property, which I'm not really going to show in on this video, but you'll see more of it in the notes, so make sure you take a look at the notes. But let's go ahead and write down the other property. It's a to the power log base a of x. Well, that also equals x. Okay, so just check out, I gave a little bit more details about the inverse property. It's in the notes, so check out the notes. But let's go ahead and use this first property and simplify some of our logs. Okay, so part A, they give me log of -3. Okay, well again, in the notes, I gave you all the definitions. So you've got some definitions of your logarithms in your notes. But you'll see that I said when you have a log, you have to take the log of a positive number. The log of 0 and the log of a negative number is undefined. So whenever you see log of a negative number or log of 0, you just get to write for your answer undefined. It doesn't matter what base they put. You'll see in the notes, if there is no base written, remember that it's base 10. This is the common logarithm. So you can put common logarithms on your calculator. That's the log button right there. That is only base 10. So make sure you have base 10 when you're using this log button on your calculator. I will show you how to put other logs in your calculator. There's a formula that we can follow, but if you're just straight pressing the log button, it better be log base 10. Well, let's go ahead. Let's pretend like we forgot that log of a negative number is undefined. Well, let's see what happens when we press it in our calculator. We've got log of -3 equals, well, look how it gives me a weird number, a comma, another weird number. That's my calculator's a way of telling me that it's undefined. Some other calculators will say error. It just depends on your calculator, but that's all just reminding you that, oh, that doesn't work. It's undefined, okay? So you can press it into your calculator, but if it's log of 0 or log of a negative number, it's going to give you something weird to remind you that it's undefined. Okay, let's try another one. Part B, I've got log of 1/100. Okay, well again in this one, they didn't give us a base, so we know it's base 10. Well, I could just put it in my calculator and get the answer. There's nobody stopping me. I've got log, parentheses, because I see I've got division, so I want to make sure that I'm taking the log of the whole thing. 1 divided by 100, close the parentheses and press enter, and it gave me an answer of -2. That is the answer. Okay, so if you have log base 10, feel free to just plug it into your calculator. But I do want to show you with this one, in case it was a different base and you couldn't just plug it into your calculator, what you would need to do. Okay, so I'm going to go ahead and just write down here that if there's no base written, it's base 10 to remind myself that the base is 10. Okay, well, we're going to use this first property. If we've got a base of 10, if we can get this number right here to be 10 as well, the answer is the exponent. So that's going to be your goal. You're going to try to get these two numbers to match, then your answer is just going to be the exponent. Okay, well, I've got 1/100. Well, let's look at 100. 10 to what power is 100? Well, 10 squared. And if you don't remember some of these, feel free to, guess and check with your calculator. See what power works. Okay, but 10 to the second power is 100. So I'm going to replace that 100 with 10 squared. That doesn't quite look like what we need yet because we need this number to be 10. We don't want the 10 to be on the bottom. Well, remember the property that tells you if you move it up to the top or if you move it down to the bottom, it just changes the sign of your exponent when you move it. Okay, so this is the same as writing log base 10 of 10 to the -2 when I move it up to the top. Well, that's what we wanted to get because our calculator told us the answer was -2, but we've done our property here. We got these two numbers to match. This just simplifies. It's whatever your exponent was. Okay, so now you have two different ways to do that problem. If it's base 10, feel free to just plug it into your calculator. And if you want practice simplifying, try to match these two numbers and then your answer is your exponent. So let's do a couple more where it's not so easy to just plug it into your calculator. Okay, so in part C, they give me log base 2 of 64. Okay, well this one is base 2, so we can't just plug it into our calculator with the log button. That's only base 10. So we've got to go ahead and do some simplifying. Well, it's base 2, so you ask yourself, 2 to what power is 64? And I played around with it before I started this video. I found when I put 2 to the 6th power in my calculator, it gave me 64. So that's what I need here. Log base 2, 2 to the 6th power is the same as 64. Try it out in your calculator. Okay, and then that's the goal. I wanted these two numbers to match. Then I know my answer is the power. So the answer here is 6. Okay, part D. They gave me ln, the cube root of e. Okay, well this one looks a little more complicated. You can put this one in your calculator because you have ln on your calculator. So that is the natural logarithm. The base for the natural logarithm is e. Okay, so whenever someone's using the natural logarithm, they usually write it this way, but you can write it as log base e. That's what the natural logarithm is. Okay, and I'm going to go ahead and not put it in my calculator. I'm going to do it by hand just so I can remind you what you can do with your radicals. Okay, so then I don't want it to be a radical. I want it to be a power because that's the only way I'm going to be able to simplify it. So remember how you can rewrite your radicals. I have an e underneath the radical, so I'm just copying that down. And then remember, the index here is the denominator of your exponent. And then whatever power is on the inside, which there's none written, so that means there's a power of 1 here. That's the number that goes in the numerator of your fraction. Okay, so remember, that's how you can rewrite your radicals. The power on the inside is the numerator, the index is the denominator. Okay, and now I've accomplished my goal. These two numbers match. 1/3 is my answer. Okay. All right, well, this is all great if you can manipulate it so that the numbers match. But sometimes you have such crazy numbers that you can't get those two numbers to easily match. There's got to be another way to do it. Well, there is. It's called the change of base formula. So let me write down the formula. We've got log base b of x equals log base a of x all over log base a of b. Okay, really you can change it to whatever base you want. They just wrote base a in the formula, but normally, because we talked about it, you would either change it to base 10 because you can use the log button on your calculator, it's base 10, or you could change it to base e because that's the natural logarithm, and that button is also on your calculator. So your whole goal is to change the problem so that you can plug it into your calculator and find the answer. Okay, so let's take a look at one of our examples. Actually, it's one of the problems we already did before. Log base 2 of 64. Okay, so we did that problem right here. We got the two numbers to match, so our exponent was our answer. But now, just in case you were having trouble doing that, you could also change this one and just put it in your calculator. So I'm going to follow my formula here. I've got log, and I'm going to use base 10 because it's usually what people like to use. So my a in this case is 10. And then the x, well, that's whatever you were taking the log of. So the 64 goes on top over log. The b is the base. That was 2. And then you just plug that into your calculator. So I've got log, and I like to put it in parentheses. It won't really matter for this one since you have just single numbers that you're taking the log of, but in case it's more complicated, I like parentheses to be in there. So I'm going to put parentheses 64, close the parentheses, then divided by log parentheses 2. Press enter, and it gave me 6. That's what we were hoping for because we had figured out that problem up here. Okay, so now you've got 2 different ways to do that problem. Let's just do one more, part B. I've got log of base 4 of 17. Okay, well, if you tried to do this one like we did this one up here, you would find it very hard to get 4 to what power gives me 17. It's really hard to find that number. Well, it's a decimal, so it won't be easy to just think about. That's why it's necessary to have this formula. Okay, so let's go ahead and write it out. We'll have log of 17 over log of 4. I like to remember the base goes on the bottom, BB, base bottom. Okay, and then just plug it into your calculator. So we've got log, parentheses, 17, parentheses, divided by log, parenthesis, 4, parenthesis, and I got about 2.04. You'll see that it continues on. Just follow the directions wherever it tells you to round. If it doesn't tell you a specific place to round it to 2 decimal places. That's usually a nice place to go. Okay? All right, so I've discussed everything I wanted to in this section. Again, it's really important to practice these problems because we're really going to need these concepts in the next couple of sections. So go ahead and do that and let me know if you have any questions.